ride a Ferris wheel after dark, and watch the shadow your seat throws on the wall behind it. The wheel turns at a steady pace, but the shadow doesn't move steadily. It slides up, slows near the top, sinks back down, and repeats forever. That gentle rise and fall goes further than you'd think. To see where it comes from, start with something much simpler: a single right triangle. Take a right triangle and pick one of its angles. Its three sides get names: the side across from your angle, the side beside it, and the long slanted side, the hypotenuse. The sine of your angle is just a ratio: the far side divided by the hypotenuse. The cosine is the near side divided by the hypotenuse, two plain numbers that capture the triangle shape. Change the angle, and those two numbers change with it. Every angle has its own sine and its own cosine, a fixed fingerprint, no matter how large or small you draw the triangle. But a right triangle can only hold an angle up to a quarter turn. What if we let the angle keep going, all the way around? Draw a circle with a radius of exactly 1, centered on a grid. Send a point walking around its edge, and draw the line from the center out to it. That line makes an angle with the horizontal. And here's the quiet magic. The point's height above the center is exactly the sine of that angle, and its distance sideways is exactly the cosine. The ratios have become coordinates. Now, the point can spin the whole way around and keep turning. Above the middle, the height is positive. Below it, the sine goes negative. It's the same triangle shadow stretched to a full circle. Push a little further and let that point keep spinning without ever stopping. Track only the point's height as the angle grows, and plot it moving left to right. The rising and falling draws out a smooth, endlessly repeating curve, the sine wave, the Ferris-wheel shadow, unrolled in time. This is why angles are best measured in radians, the distance traveled around a circle of radius. 1, because that is the natural clock for anything that cycles. Sine and cosine are the mathematics of rotation and oscillation, a swinging pendulum, a sound wave, alternating current, a planet's orbit, all trace the very same curve. From the shadow on a Ferris wheel wall, to a ratio in a triangle, to a point circling a unit circle, to a wave with no end. Sine and cosine turn going around into going up and down. That is trigonometry, the shape of everything that repeats.